Live from New York, it's Ask an Engineer. It's time to boot up.
I know. It's the Hackers anniversary. It was like 10 years ago, right? When Hackers came out? 15. No more than 20.
Little over 10 years ago.
A little more 10 years
But then there's the... it's like dog years.
Yeah. All right. It's Ask Engineer. It's me, Lady A, the engineer, with me, Mr. Lady on camera control. We're going to have a little bit of a speed show tonight.
Yeah.
We're going to get to all the important stuff.
Let's
kick it.
Yeah, we're going to do a discount code. We're going to do new products. We're going to do INMPI. And then just so y'all know, we're setting up our studio here so we can do a lot more and do more shows and then do more pre-records and have just more content. We have a lot more space. You can't see behind here, but you will eventually.
Are we stopping?
No.
Are we giving up?
No.
Are we quitting?
No, but we are going to give you 10% off.
Bam.
4-color. That's in celebration of a 4-color ink display, of course. We'll talk about a couple folks who showed on the show and tell just real fast right before we go. And then, because it's shout outs and stuff, I did want to mention, actually, I'll just do it now. Really cool demo of Fruit Jam that JP did. Of course, you saw the intro with Liz. And then I think
he did the overlay. Liz did the Atari video
thing
sample just talked
and then
about.
Mark was getting his pilot license as this cool thing. And then Roberta came back, has this cool thing
name
from
sign.
And then Aaron had the magic mirror. And that was a sparkle motion.
And Noah had the 3D printed Fruit Jam OS.
It's like a full computer. Anyways, that's what it
yeah.
is. So that's our recap of that. Save a buck or two while we go into all of the new products and all the things that we do each week. Let's start it off with NPI.
Okay.
Because we got to do that right away.
On NPI.
Hi on NPI, brought to you by DigiKey and Adafruit. This week it is microchip. Lady Ada, if you could just dive right in.
Yeah, that's right.
Kick it.
Okay, so this week we've got the MCP 41 and 42 U83. These are some really nice single and dual channel digipots with digital control, SPI or I2C. They did a really nice job with these pots. I'm probably going to make a breakout for them because they've got stuff like non-volatile memory, 10 bits, really good bandwidth measurements, and of course, variable values from 5K to 100K. Everyone knows potentiometers. You know them, you use them, you twist the knob, resistance changes. DigiKey stocks like 715,000 different types of potentiometers. I mean, like, they're so good at converting mechanical movement into an electrical signal. And they all pretty much, other than wire wound and some other kind of, exotic ones, the vast majority of them work the same way. There is, here's a pot that's been taken apart. On the very left and the very right contacts, there is a conductive material that goes around in a circle or goes in a line. And then in the middle, you see those little fingers. That's the wiper. And the wiper swings around and contacts the middle pin to a point between the left and between the right. And as you twist it, it goes from the very bottom of the resistance to the very top of the resistance. So, you've seen them as volume knobs, trimmers. There's surface mount potentiometers like these, where you use little Phillips or flathead screws to adjust them. And, people use them a lot. I use them a ton all the time to trim values, to adjust settings. They're inexpensive, they're easy to use, but there are some downsides. One is they are susceptible to mechanical failure. Like I found this cool video on how to revive old stereo systems and ham radio equipment that has pots that go bad, because eventually that ceramic material can flake off. It can get scratched off by the wiper. Their oil or gunk can get in there because they're not usually sealed. So they do have a lot of failures. And if you have trim pots, if they're vibrated, they can come loose. People often would use a little bit of glue or something to keep them from moving around. And so there's also times where, you want to maybe adjust an analog voltage or resistance, and you don't want to tell people, okay, open up the case and get your potentiometer, little knob and twist it. So instead you could use a digital potentiometer, and this kind of works the way you think. You basically get, you power it with, 2.7 to 5.5 volts, and you connect to it over I2C, or SPI in this case is also available. And you basically tell it what value you want, and it will move the wiper. And inside there's this string of resistors, like literally there's 1,023 resistor terminals for every single one of the 10-bit values. That's why it's kind of nice, because sometimes most potentiometers kind of top out at 7-bit, but this goes up to 10-bit. This one can do also split supplies, although the total amount of supply between VSS and VDD still has to be under 5.5 volts. So it's not like a wide voltage range, but you can do split supply for analog voltages, split analog projects. And one thing that I thought was kind of nice is low total harmonic distortion, low noise density, especially when you're talking about the 5K or 10K value. And the bandwidth is really good too. You can get like tens of megahertz through here. So this is fine for, low grade radio, not super high speed, but, like tens of megahertz. Audio for sure, filters, sensor signals. So it's a great way to replace a potentiometer. What's nice is also with the 10-bit resolution, you're going to get more repeatability and accuracy than with a trimmer. Like you're not going to be able to twist a trimmer to 1/1000th of its value, whereas you can tweak this digipot to 1/1000th. 1/1000th of its value. To communicate with it, you send messages over I2C or SPI. It's a standard SM bus interface. There's both RAM, like dynamic memory, and non-volatile NV memories. So for example, you can write a value potentiometer, and then when the product starts up the next time, it's automatically set to the value that it was set to before. So you immediately synchronize to the whatever you set the trimmer to before. One note, it does have a maximum write life of 1,000 times. So it's not like you can write to permanent memory on every twist if there's like a volume knob, but you can set it, when you are about to power off or something, or maybe once every few minutes, or if the trimmer's only set in the field or to account for temperature, humidity or something, 1,000 times will cover you. It's available in both TSOP and QFN. This is the single. There's also the dual, same package, just, the non-connect pins are a separate potentiometer. And all the variants are in stock right now at DigiKey, so 5K up to 100K, TSOP, QFN, single, dual, they're all available. But, if you want to start with one, start with, I think, what did I pick out here? This is like the 10K QFN. I think this is what I would start with. A nice, low cost, under $2, and easy to pick and place, easy to use. Microchip has a great data sheet. I went through it. It explained everything very well. And
high praise.
The driver should be easy to write. So, I'll probably make a breakout for this, but check it out. I like the non-volatile. 10-bit is unusual. So very high resolution, high repeatability for a digipot. Check out the MCP 41 and 42 U3 83 series, available now at DigiKey.
All right.
Eye on NPI.
minor change of plan. So what we're going to do is we're going to end the show now because we have to go take care of our kiddo. And then if we can, she's asleep by now. Babysitter's asleep. If we can come back on the show, we'll start up a new one and do new products.
Okay.
If we can't, we'll just record it when there's no chance that we'll have to leave live on air because I don't want to do that.
We were delayed. There was a bit of a kiddo request. We wanted to honor that request.
Yeah.
We don't get a lot of them.
Yeah. So we'll see you in a bit. So thanks for watching Ask an Engineer tonight. Use the code. The code, I'll keep it on even longer than usual. And we might do just like a live new products tomorrow, or we'll do something else. But I hope that you all see, as we've done Ask an Engineer from the start of it, which was me shipping a package. We had a free webcam. This was like 20 years ago. And someone said, if I buy something, will you ship my order? Thus begun Ask an Engineer, because they said, sure. And they go, I have some questions. It's like, well, you can ask the engineer.
You know what we should do is people should request like a breakup board design or library, like a live code it right there. And
Vibe code it.
yeah, vibe code it.
We do interpretive dances now. So, it's kind of neat that we're already able to do this now. 20 years is not that long. Think about it. Like, this is amazing. We can do this show. And it started off as just doing Saturday nights.
Yeah.
As we were growing up together. So come by, join us. We're here every Wednesday in some way, shape, or form, but we'll also have this new product video up, and we'll see everybody
Okay.
for the week.
Maybe we'll see you in a little bit. Maybe we'll see you tomorrow.
Yeah, let's build some stuff together, everyone. This has been Adafruit Production. We'll see you all very, very soon. Here is your moment of Zener.
Good night.